Good afternoon. Kavitha said that only the strong survive. I think only the resilient survive. So, before we move forward, safe harbor, there's some forward-looking statements here. Let's get into it. So, unprecedented cloud resilience. What is it? What does it take? All of these numbers, by the way, are available at the Zscaler website. You can come in and look at any time how the cloud is doing. But you've heard throughout the event, we're serving 7,000 organizations, about 50 million of their users, 300 billion transactions per day, right? And in certain days, we see peaks of 8 million transactions per second. This is truly scale. So how do you build a cloud of this size? What does it take? Well, first and foremost, it takes a lot of blood, sweat, and tears, right? Millions of man-hours of experience. But if you were to boil down all these efforts, really, it would be these 4 ingredients. We start with capacity. You have to have enough capacity to serve the 50 million plus users that connect to the cloud. But it's not just everyday capacity where users are coming and going. Very often you have scaling events, company all hands, you have tax season, you have holiday season, and so you have to have enough capacity to deal with these things. But there's also times when capacity disappears, cable cuts, ISP interruptions, so you have to have enough to support anything that the world throws at you. Once you're done with capacity, availability. People have to be able to get to the cloud. And don't forget, I say many times, Zscaler is not a destination. People go through us to get somewhere. So not only do people have to get to the cloud has to get to the destination, whether it's a Microsoft application or a workload or a customer's data center. Once availability is there, security is important. This whole event was about the product innovations in security that Zscaler is bringing to our customers. However, Zscaler itself is built as a zero trust platform. So security behind the scenes is also just as critical. And once you have all of this, we go to performance. So what is performance on a security cloud? Well, it's definitely not CPUs and servers. It's not your traditional, hyperscaler environment. What performance to us is really about user experience. And if you ask users, what is a good user experience of a security cloud? Well, really, they don't want to know that it even exists. So when the users don't know we're there, that's when we're doing a great job. So taking a step back, what's a day in the life of the world's largest security cloud? We run about 150 data centers worldwide. Those data centers receive over 250,000 updates per day, all of them that people basically don't notice them. We process 300 billion of our customers' transactions. Those transactions culminate in about 500 trillion metrics that we have to get insights from. And generally, all of this works great. But because we operate all over the world at this scale, there's always a problem somewhere. Now, if anybody has ever been to an airport, you can always find one delayed flight on the board, right? And airports serve a couple of hundred flights per day. Well, Zscaler, we have 300 billion flights per day that we have to figure out which one is delayed and how it's impacted, and specifically how the user impact or user experience is during these events, and then what to do about them. So the question is, how do we go about doing this? We started just like everybody else. We started looking at building monitoring and various telemetry, but what we found is that looking from the cloud to the world does not equal user experience. It shows you the health of the cloud, but it doesn't show you user experience. And so this is where Zscaler is truly unique. Many of you have heard, there we go. Many of you have heard about our ZDX product, Zscaler Digital Experience. At the core, what ZDX does is it collects metrics from millions and millions of users that are actively using the cloud. So relevant user experience merged with our view from the cloud gives us a unique ability to detect user performance impact problems anywhere in the world and anywhere they happen. Having this data is great. It's very important. But you also must be able to do something about it. And so what we realized a long time ago is that ensuring performance at every path is critical to ensure a good user experience. But to ensure performance at every path, you must have control over every path. This is part of the reason why Zscaler has built their own network, their own infrastructure, and we run our own code. Now, when you ask users, or when you ask most operators what happens, where the problem usually happens, they usually tell you it's right here, in the up direction. So the typical complaint we get is, I can't get to Zscaler. But remember, Zscaler is not a destination. There are problems sometimes in this area, but this is only 25% of the equation. The other 75% of the equation also must work. So the question is, how do we solve for the other 75%? And to answer this question, I would like to welcome Diana Vikutan.
Hi, Misha. Great to be here.
Good to have you.
Thank you.
So, Diana, incidents and outages, or outages specifically, are really easy to detect.
Oh.
You can tell when something is down. But I'm having a hard time even explaining what user performance is in words. How do you actually detect it in a cloud that runs 300 billion transactions per day?
Yes, when an incident, when something is completely down, it's actually easy to detect, even at our scale. But problems associated with user experience and performance are harder. And this is what we wanted to solve and figure out for our users to help them to round around those issues and restore performance. What you see here is our latest innovation, ZDX dashboard, that we use for cloud apps. It shows the performance overview at all our locations. And normally, it looks like this. Everything is great. There's no problems. Things starting to appear great. But Misha, it's only temporarily, right? Just like in news, if you follow technical or otherwise, there's always something's happening somewhere. So on March 21st, we detected the performance outage that was happening with our users in Singapore area.
So, OK, it looks like there's a problem in Singapore. That should be very easily defined and very easy to fix, right?
Not really. So usually, the problems like that will disappear, right? But sometimes we have to intervene. And before we do that, in this particular case, it actually was not resolving on its own. So what we first do is we need to look what happened prior to the incident for us to analyze the whole picture, right?
So let's dig in.
Yeah, so let's look at Singapore just prior to incident. And this is how it looks like, right? So on your left, you see all the ISPs that our users use. In the middle, ISPs that Zscaler use. And all the way to the right are the Zscaler. So this is just for the Singapore itself. And it looks normal, right? There's no problems. But we're starting to notice that something was happening between two major ISP providers in Asia, Singtel and Telstra.
OK. So basically, what you're telling me is you have to look through 500 trillion transactions, or 500 trillion metrics, 300 billion transactions, millions of users, thousands of their ISPs, to get to know that something is wrong between something in Singapore between Singtel and Telstra. Why does it sound like there's something more to this?
Yeah, so like I said, automatically some of those issues go away, right? But sometimes we actually need to intervene. So in this case, the performance actually degraded even further. So our network and infrastructure team need to take action. But even looking at the connectivity between the two providers are not that simple, right? So we need to look even deeper and understand what all the connection points look like. So on this graph, you see all the connection points that exist between the two providers, only in the Singapore area alone. And then we see that there's a 3 unique paths between the Singtel and Telstra. 2 of them are OK, but 1 is impacted. So driven by AI and machine learning, and having this data at our fingertips allows us not only to observe, detect, but also remediate and know exactly what to do in a short period of time, which is the key of ensuring good user experience. So our networking team optimized the route by sending the impacted path through NTT, but leaving the unimpacted path through its original routes through Telstra, thus reducing any impact to the users. In this particular examples, all the routes were outside of user ability to change, but Zscaler was able to detect and remediate and ensure good user performance.
Wow, Diana, thank you. This is really powerful.
Thank you, Misha.
Thank you. So having this type of data is absolutely critical for decision making. And even a lot of this is remediated automatically. Giving this to operators with the granularity that we have it, that ZDX collects, is really important for them to solve these problems a lot faster. As you can see, the world is very complex, even at the level of Singapore. Now, we talked about how to remediate the 75%, but this path could still have problems. And if you think about this forward path, well, generally, where is it? This path is usually some home user that doesn't have control of their internet, that is usually not technical, and can't influence their network. So how can you ensure performance and user experience on a path that you don't control? Here to talk about this, I would like to welcome David Ma from Charles Schwab and Lidor Pergament. Hey, David. Lidor.
Yeah, thank you, Misha. Oops. Thanks, David, for joining us. So let's start with the physical world analogy to the problem Misha was alluding to. So imagine you have a user traveling from point A to B, in this case, station 7 to station 3. As we all know, in a good day, usually the direct path is the best path to get to the destination. However, disruptions happen in the physical world. It could be congestion, it could be construction, and then what a user would typically do is look for a different path to get from point A to B. In this case, you would reroute somewhere from the east here to get to the destination. Now, David, again, thanks for joining us today.
Absolutely.
Help us translate this kind of physical world example to the network connectivity world at Schwab.
Absolutely. So over the course of the last couple of years, Charles Schwab's workforce transitioned, much like everybody else here, into a more mobile environment. And well, when we introduce that mobility into the environment, that introduces complexity, right? It introduces complexity and also introduces the ability to be able to leverage, right, technology to be able to resolve those issues.
Yep. Thanks, David. So I'd say definitely not an unusual problem. We've heard many customers talk about people working from anywhere, twice a week, 3 times a week. You'd see millions of people go work from home. And the challenge is they're on an unmanaged network where the IT team typically doesn't have control over, and disruptions, as we know, always happen, especially at the last mile ISP. So I'd like to start by talking about an innovation that we just brought to the market as part of Client Connector version 4.2. The innovation is dynamic path selection for automatically optimizing the end user experience on an individual end user basis. And so let's look at how it works from an actual example that happened just a week ago in the Florida area. So we observed a user running Client Connector somewhere in the western part of Florida, maybe next to the Tampa area. The user was trying to get to some application somewhere in South Carolina on the East Coast, and obviously the best path is usually through the nearest data center, in this case, the Miami DC, from which we saw 10 millisecond latency. However, as we all know, network conditions change over time. In this case, we saw the network latency jump all the way up to 110 milliseconds. And the reason is, in this case, if you looked at the ZDX cloud path for this specific customer, we saw an increase or congestion between the last mile ISP, which is AT&T in this case, and one of our providers in the Miami DC, which was Aurelian. Now, regardless of the root cause, which is a different topic, investigate, what we first want to do is, as quickly as possible, mitigate the end user experience challenge. And that's exactly what this capability does. It's very easy to configure. All you need to do is check this box in the Client Connector app profile window. The moment you check the box, Client Connector starts probing 2 DCs for network path latency. In this case, you can see the second DC is Atlanta. It noticed that the latency to the alternative DC is much better, 26 milliseconds in that case. And the moment it observed the better network path performance, it automatically switched the tunnel from Miami to Atlanta. And the important thing is this was completely transparent to the end user and required zero intervention from the operator, from the customer in this case. The only thing the end user may have noticed if they opened up their client connector window would be the simple message that this change happened. And the reason is obviously there's a different path. We can see in this case, again, AT&T is the last mile ISP, but landed on a provider, one of our providers in the Atlanta DC, which was Zayo. So David, what are your thoughts here on this?
That's incredible, Lidor. I mean, these days restoring service usually requires troubleshooting, isolation, and most times manual intervention. But with Zscaler's dynamic path selection, that really empowers our user community to be able to dynamically fail over and really provide that consistent, best performing user experience. I mean, it's amazing. I mean, I come from a networking background, and to be honest with you, if I was going to compare this with any kind of network technology, I would compare it with IPSLA at the agent level. It's incredible.
Yeah, love that analogy. So David, there's always we call those brownouts, the temporary degradations. But every customer, I'm sure you have strong business continuity plans. You want to hope for the best, plan for the worst. So many of our customers ask us, hey, what about these extreme scenarios where, let's say in this case, both the Miami DC and the Atlanta DC are not accessible due to some black swan type of event. So to solve this specific problem, we just launched, again, in general availability, a new service, a new solution called Disaster Recovery. It's available both for the ZIA and for ZPA, for internet apps, and for private applications. Now let me explain how it works, just staying in the same geographical area. So first, before you enter this DR mode, whether it's testing, whether it's in live disaster, you first need to configure it. It's very simple, just a few simple steps. You'd go to your client connector portal, to the app profile window. You'd switch this knob. You then pre-select a few destinations or critical applications, essentially, that you want to ensure access to even during this disaster scenario. You would then pre-configure a DNS text record, which would be used to trigger DR and basically signal the client connectors that they need to enter the special DR mode. For the ZPA case, you'd also need to ensure that you have a private service edge hosted in your infrastructure, which is fault isolated from the public cloud. And you need to make sure you switch this knob, which enables disaster recovery for those PSEs. Now, the moment you're ready, whether you want to test DR, whether you want to actually activate it during the black swan event, simple change. You just go to your DNS, update the text record, as you can see here. From that point on, client connector knows that DR is activated and it switches into the special mode of DR. Now, more specifically, the way it works, for internet applications, client connector enforces local policy on the endpoint, allowing access only to predefined trusted destinations, such as your Microsoft 365 applications and so forth. For ZPA, again, we have the private service edge in play here. It's fault isolated from the public cloud, hosted by the customer in their own DC. And the way it would work, client connector and the app connector, which is fronting your private application, redirect the traffic through the private service edge hosted, again, in your infrastructure, and ensuring that even during these extreme scenarios, your users can continue accessing those critical applications. Now, David, I know you've been on a PSE journey at Schwab, so maybe you want to share some insights.
Sure. So Charles Schwab invested in our private service edges really as a strategic approach to migrating off of our legacy platforms. However, this continued Zscaler investment in the capabilities and the features of the private service edges truly identifies the value that we're getting out of these private service edges by delivering disaster recovery capabilities. Yeah. I mean, it's an amazing capability. We're definitely looking forward to it and implementing that within Charles Schwab. And Lidor, to be honest with you, business continuity, right, is a critical strategy for Charles Schwab.
Yeah.
So let's talk about some extreme scenarios.
Yeah.
Right?
Yeah.
So in the event of failure of both data centers, what happens?
Yeah. Yeah. So again, in the extreme event, we have the solution. We go direct, enable local policies for internet access.
Excellent.
You go through the private service edge for the private applications, Again, you ensure for this temporary period where the public DCs are not available, you continue accessing those critical applications.
I also want to tell you that it's amazing to see Zscaler's growth in the Zscaler Client Connector. It provides multifunctional capabilities and innovation all under a common agent. I mean, how many of us can say that we run DLP, disaster recovery, proxy, and VPN-like services through one agent? It's impressive.
Yeah. Thank you, David, for the insights. So again, I just want to emphasize that these are two out of many string of innovations we're making across reliability, availability, scalability of the cloud to ensure, in the end of the day, that our customers are resilient in spite of these disruptions that we all know can happen at one point. So again, thank you, David, for your time, and I'll hand it off to Misha to wrap up. Thank you.
Thank you, David. Thank you, Lidor. So you can now see how we can ensure performance at every path and guarantee a level of user experience that is unparalleled to anybody else. With these innovations, Zscaler is bringing to market a better way to use the world's biggest security cloud. Now, you can rest assured that we'll continue to innovate in observability, in performance, security, and other products, and bring those products to our customers and partners, and also use them internally. Zscaler has a long history of innovation, and we also understand our position as a critical infrastructure company for our customers. We are an extension of our customers' network. And we understand that it's not just about technology. We also want to make sure that customers have validated trust and verified trust. This is why we invest in compliance. And we want to guarantee that the future, any workload, or Zscaler is fit for purpose for any workload, any user, anywhere in the world. It's truly humbling to look at what 15 years of innovation looks like. Zscaler operates at an unprecedented scale. And if there's one thing that I want to leave you with, is that there is no compression algorithm for experience. I look forward to the future, and with that, I want to thank our partners, our customers, and hopefully you enjoyed this segment. Thank you.